Okay, so yesterday we started out looking at mole to particle conversions and then also particle to mole conversions. It works exactly the same way. Okay? Doesn't matter whether you're going from moles to particles or particles to moles, you use the same equality statement. Remember that equality statement is that there are 6.02 times 10 to the 23rd particles of some species. Okay, I want to use X as the species here, just to have something there. Yeah. Yeah. Wait a minute. Where's the bathroom pass? Oh, it's on the floor. Okay. All right. 6.02 times 10 to the 23rd particles of X equals 1 mole of that same species, in this case X. Okay? And particles can be just about anything. Alright? It can be atoms. It can be molecules. It can be ions. That's up to you. I'm just kind of reviewing right now. Okay? Ions, so it can be polyatomic or monoatomic, any kind of ion. Okay? It can be electrons or protons, neutrons. Okay? It could be Dorn High School students. Any kind of particles. It could be oranges. Okay? Any kind of things that it is a discrete, separate kind of thing. Okay? And so, whatever kind of particles those are, okay, that same species, whatever that species is for these particles, also has to be the same species over here. So these have to be the same. That's why I've listed it as X. Those have to be the same. Okay? So let's say that I have 12.5 moles of electrons. And I want to find how many electrons that comes out to be. Okay? So I'm going to use this equality statement here. I'm just going to plug in electrons there. Okay? So particles can be electrons. So I'm going to write this equality statement in this way. I'm going to say 6.02 times 10 to the 23rd power of my particle is an electron here. Electrons equals 1 mole of those electrons. Now you may notice I use MOL sometimes, or MOLE. Either one of those is fine. This is an English spelling and this is a Latin spelling. Either one of those is fine. Okay? So this then becomes our starting amount. This is what we have. This is what we're trying to find. So this has to be the starting amount here. And starting amounts always go where when we're converting? On top of 1. Okay. So in a fraction over 1. 12.5 moles. Okay, y'all mind if I write a shorthand for electrons? You can write out the whole name, or you can just use a symbol. In this case, that's a symbol for electrons, okay? And I'm going to put it over 1, like some of you said. And then I need to convert. I've got to have this fraction called a conversion unit. To convert, I've got to have this fraction called a conversion unit. Okay? Now, to write the conversion unit, I need an equality statement. So the equality statement had to be done before you can do the conversion unit. And then what you do is you look at the equality statement here and choose the side of the equality statement that matches the previous steps, units, and species. And you put that side of the equality statement on the bottom. Okay, let me repeat that one more time. You choose the side of the equality statement that has the same units and species as the units and species in the previous step. And you put that side of the equality statement on the bottom of the conversion unit. Does that make sense? Okay, so look at this. Here's the equality statement we're going to need if we're going to go from some kind of particles to some kind of to moles. If we're going from particles to moles, this is always the numerical values we need for this equality statement. So which side am I going to put on the bottom? The right or the left? The right side. Moles of electrons matches moles of electrons. That makes sense? Goes on the bottom. 1 mole of electrons is going to go on the bottom. And the other side of the equality statement goes on the top. 6.02 times 10 to the 23rd electrons goes on the top. Okay? So what do I do next, Malik? Yeah, we're going to cross out the moles. Okay. Brenda, what else do I do? Well, we will, but there's really something else we need to do first. Yeah, we can cross out, this is the species, we can cross that out too. It's exactly the same, isn't it? Okay, so we can cross that out. Now we're ready to multiply across. Since both values here are on the top, then we're going to do multiply. So this is where you need your trusty calculator. Okay, get out your trusty calculator. Everybody get out their trusty calculator. Now, most of you will be able to put it in your calculator. And even though you can do this without parentheses, I'm going to suggest you get used to using the parentheses to set apart different operations. So what I would suggest you do is you put in 12.5, hit your times button, then put in a parentheses. So you got a button that has some kind of parentheses, open parentheses, then 6.02. A lot of you are going to have a button that has an E on it or a double E. Some of you have a button that says EXP. Yeah, and occasionally your buttons can even say 10 to some X power or something like that. Those are all the same thing, same kind of buttons. Yours may say EXP or something, okay? But those are all the same thing. 23, not times 23, exponent button 23 will give you the same thing. And then you're going to close your parentheses and then hit your equals button, okay? So this is how we're learning to use the syntax of your calculator. Okay, so I've done mine. I don't know if you can see it for the shadow or not, but that's what I've done there. Okay, and I got an answer that is 7.525. My calculator says E24, which means times 10 to the 24th power. Okay, so and what I have left are electrons. Now, since I've done the mathematical operation, I need to fix my significant digits at the end. Okay? So I'm going to look at all the numbers in the problem, and that would be this number and this number, because these are counting numbers at the bottom. We only worry about these two right here, and 10 to the 23 isn't included because 10 to the 23 is at a, what's that called? Order of magnitude. Okay, it's not really the significant digits. These are the significant digits. So look at this number, and find the one with the least significant digits. Well, they're the same, aren't they? There's 3 significant digits. So that's how many I need my final answer. Underline the last digit then, because that will give me the 3 that are remaining. Draw an arrow, and then it becomes 7.53 times 10 to the 24th. You can't leave that off. That's the order of magnitude electrons.
Why do you times this one instead of dividing it like the other one?
Because the numbers are across the top. If you got a number on the top and one on the bottom, that's division. Okay? Does that make sense? All right. Now, in this unit, we're going to be doing a lot of conversions. This is just one kind of conversion. Okay? So this converting from some kind of particle to moles, or converting from moles to some kind of particles. It's always going to use this relationship where you have Avogadro's number right here equals a mole of those things. And then you build a conversion unit. We did it yesterday. We've done one more again today just to kind of bring you back up to speed. All right? Now we're going to go on to a different kind of conversion. Okay? Where we don't go from particles to moles or moles to particles. We go from mass to moles or moles to mass. Okay? And so for that we're going to learn to do molar mass conversions. Molar mass conversions. If you want to give it a title, some people do.